The purpose of this lesson is for you to be able to use prime factorization to find the least common multiple of a pair or group of numbers. Prime factorization is when a number is expressed as a product of prime factors. You can use a factor tree to find the prime factorization of a number. The example below shows a factorization of 12. 12 is the top of the tree. Then the next pair is 2 and 6 because 2 times 6 makes 12. Since 2 is prime, we don't do any more branches from there. However, because 6 is the product of 2 times 3, that branches down into 2 and 3. The only thing left now at the end of each branch is a prime number, 2 times 2 times 4. So if you notice, 2 times 2 is 4, 2 times 2 is 4 times 3 is 12, which was the number we factorized. So to find the prime factorization of 18, you would find multiples of 18. How about 6 and 3? So 6 and 3 multiply to give you 18. 3 is prime, so there won't be any more branches. And 6 is a product of 2 and 3. So the factorization is 18 equals 2 times 3 times 3. Let's try another one. Let's try 100. Two things that multiply together to give me 100. Doesn't matter which two things, it all works out the same, but I'm going to go 25 and 4. So 25 is not prime, it is the product of 5 and 5. Those two are prime numbers. And 4 is not prime, it is the product of 2 and 2. Those are both prime numbers. So 100's prime factorization is 2 times 2 times 5 times 5. Least common multiple. The least common multiple is the smallest multiple that is exactly divisible by every member of a set of numbers. Finding a least common multiple is part of the process to adding and subtracting fractions with unlike denominators, so it's very important. Writing down a list of multiples is an okay method as long as the numbers are relatively small. But what if the numbers are 84 and 90? Then making a list of multiples is not too cool. Fortunately, we have a better method. Prime factorization is the better method. To prime factor numbers, you would start by making a factor tree, just like we did before. Then you'd write the least common multiple, which is below the factor tree. Considering each prime number, write it the greatest number of times it occurs in any one factorization. So notice in 15, 3 occurs once, and in 24, 3 occurs once. So that's the highest number of times it occurs in any one. So there's 1, 3. In 24, 2 occurs 3 times. So there's 3 2's in the least common multiple. And in 15, 5 occurs once. So there's 1, 5. And when I multiply 2 times 2 times 2 times 3 times 5, I get 120. So when you try 35 times 90, you should get an answer of 630. Let's try it together. Find the least common multiple of 21 and 28. Well, 28 factors into 4 and 7. 7 is prime, so we won't want any more branches there. 4 becomes 2 and 2. So 28 factors into 2 times 2 times 7. 21 factors into 3 times 7. So writing it that way. Now notice 28 has 2 2's and a 7, and 21 has 1 3 and 1 7. Well, since a 7 is in both of them and it only occurs one time, it's only in my least common multiple one time. So the least common multiple is going to be 2 times 2 from the 28, 3 from the 21, and 7 from both of them. So the least common multiple is 84. Trying it again, we just did 28, 4 and 7, which gave me 2, 2, and 7. 21, which was 3 and 7. And 9, which is 3 and 3. So when I look at this now, I have the least common multiple. The 2 times 2 comes from the highest number of 2's, which is in 28. The 3 times 3 comes from the highest number of 3's, which is in 9. So I put 2 3's in it since I have 2 3's in 9. And then 7 comes from 21. So I have all the prime numbers that I see in my factor trees, and I have the highest number occurring in any one number. So 2 times 2 times 3 times 3 times 7 is 252. It's your turn. Find the least common multiple of the numbers. Pause, give it a try. Did you get the least common multiple of 14, 21, and 7 is 42? Try the next one. Did you get 21? The least common multiple of 21, 11, and 55 is 3 times 5 times 11, which is 165. I hope so. That's all we have. See you with your questions.